Hi everyone, welcome to this short video. I just wanted to quickly touch upon a question that came up in the office hours today. And so I just thought I'll give you an example and show you what really is going on because we haven't discussed this in class yet. So this is a problem we did in the lecture today, and a similar problem is there in homework 5 problem 2, and problem 1 also has some flavor of this. So the question is that in class, by using the formula that you have on the left hand side, that is f external is equal to rho v dot nvda. On this geometry that you have on the right, we derive this result f external, which is two component I cap and j cap, and depends on cos theta sine theta of a2. And we did the balance in class, and you will be doing similar problems also in your homework. Now we can calculate the right hand side, which is using this sort of balance of control surfaces. But the question is, what happens to the left-hand side, external? And as we discussed, the F external takes into account pressure forces, shear forces, gravitational forces, and so on. So on the left-hand side, really, this F external, how should we include the atmospheric pressure? So that is really the question. And the short answer is that we never include the atmospheric pressure, and we only need to account for the gauge pressure as written here. So we only need to account for the gauge pressure, and we don't have to worry about the atmospheric pressure. And why is that, right? So that is a natural question. One might think, well, if I have an atmospheric pressure of P1 plus P atm here and P2 plus P atm here, then I'm actually pushing the surface from the bottom and from the top, but those are not aligned at the same angle. So in a way, my P atm at the exit should point differently in force to the one at the entry. So I should not be able to cancel P atm. However, note that P atm also comes, on these all the walls here, all the walls, and that never goes away. We really still have atmospheric pressure everywhere. If we're using it at one point, we know in the air it will be everywhere, even though the water is not flowing. So on those walls, we can still experience atmospheric pressure. And so if you want to calculate within F external the contribution of atmospheric pressure, we have to integrate minus P atm and dA. And so why am I having a negative sign? Because we know pressure force always pushes. And so it pushes into the fluid, always pushes, and out, and n vector is pointing outwards. So pushing is inwards, and that is minus of n vector. And we can basically, because P atm is constant, we can take it out, and we get n vector dA on all the surfaces, including the boundaries where there is no flow and so on, because atmospheric pressure goes everywhere. And you can essentially prove this. It doesn't take too long. You can kind of show that n vector dA is actually equal to 0. Why? Because you can write nx I hat dA minus P atm plus ny j hat dA plus nz k hat dA, right? And so this is essentially one way you can write this, and you can write this as, and I'm just showing a quick derivation for this, n dot I hat dA plus n dot j hat. Sorry, let me maybe just take out I hat from here. I hat like this, dA. And don't worry, even if you're not following this, it's all right. I'm just showing you like a derivation, n dot k hat dA, right? And if I have an n dot some vector times dA, then I can use divergence theorem. And converting a divergence theorem means that whatever this value I had, I have to take this is my vector because this is being dotted with n. And so if you take a dot product with n, then you can convert it into a divergence theorem. You can take a divergence of I hat, but a divergence has derivatives, and I hat, j hat, k hat are constants. So when you take into account of that, you can basically be able to convince yourself that it is zero vector or simply zero. And so this essentially atmospheric pressure cancels out. And even if you didn't understand the maths, don't worry. It's not important. I'm happy to chat about it if you're interested. But in simple terms, you just should not use atmospheric pressure in the force calculation. Now, for the homework problem, if you did use the atmospheric pressure in your calculations, don't worry. You'll not detect points, but going forward, just remember you only have to use the gauge pressures. And this is just, I just wanted to clarify that, okay? So we discussed how the atmospheric pressure drops out because of the divergence theorem. And so in future for external forces, only use the gauge pressure. All right. With that, we'll close the video and I look forward to seeing you in the next video.